Howdy everybody, Mr. Bob, your neighborhood naturalist, Bob Langston from the North Carolina Zoo. I hope everyone had a wonderful holiday season, and here we are getting ready to face 2021. Has a lot of promise and maybe a little bit of change. But first, we're going to spend a little time today talking dirty. Okay, maybe not what you think. How about talking about dirt? Or talking about mineral soils? How about that? Is that a little bit better? Okay. Those of us who live around Randolph County and pretty much across the southeast are really familiar with this substance right here. I repotted, I moved a plant actually. I dug it up from one spot and moved it to another, and while digging in the dirt, this is what I came up with. And I often joke about it that here in Randolph County we don't exactly have soil. We have red clay and rocks. And so we'll talk a little bit about what those are in just a second. But this is our typical red clay. Now, in some cases, it's really good, and in some cases, not so good. So I'll get into some of those as we go. When you talk about mineral soils, and that means soils that have had pretty much all of the nutrients, all of the organic matter, leaf litter and stuff like that, that's been consumed by plants and other things, you get down into various particle sizes. And a lot of times it's made out of the same kind of stuff, a silica, sometimes there's some other stuff in it as well. On the large side, the largest particles are sand. And there's about 5 or 6 degrees of sand. There's coarse sand, there's stuff. Once you get above sand, it becomes gravel. So that's one of those things. On the smallest side, the smallest particles that you can find of any type of soil are called clay. And so the tiniest clays have the finest particle size. And that's good for a lot of reasons. It's also bad for a few, and I'll explain more again as I mentioned. So let's talk a little bit about the particle size. You start off with the small particles, and the smallest ones are the clays. They're itty-bitty, really tiny. And when scientists are looking at them under a microscope, often they're only able to look at the actual size across here. And they don't look at the, actual volume and everything of the grains. So we're just going to talk about size for a second. And that's kind of a big deal. So in the middle, by the way, you start with clay as the smallest stuff. And clay can be made of a lot of different minerals. Like I said, a lot of times it's silica, but there are other minerals as well that can be in there. But on the small end, you've got clay. On the big end, you've got sand. And in the middle is a material called silt. So they're basically 3 grades of really small stuff. There's 2 different sizes of clay, larger clay, silt, and then you get small, fine sand and stuff like that. So even the finest sands are bigger than clay particles. The reason I'm holding this little square right here in my hand, this is an 1.5 inch square. And if you want to look at the total area, it's like 2.25 square inches. So this is a 1.5 inch square of polyethylene plastic. And if this was a particle of clay, by comparison, and we're just talking about comparison here, if you had a piece of clay this big, this 4-foot square piece of the same material that's hanging off my barn over here, this would be the largest particle of sand. So clay is tiny, sand is large, and that's as far as particles go. And that does some odd things in the world. As I said, one of the issues is that when you look at them under a microscope, you can measure the distance across the particle, but you may not necessarily get the idea of its shape. And so most of the particles of soil, of dirt, mineral dirt and things like that, are not uniquely flat. They have odd shapes and contours and stuff like that. And the odd shapes and contours mean that a lot of times this stuff doesn't pack together. There's space in between it. And that space contains air, and when it rains, like it's been doing around here, it also contains water. Now sand, with the large particles, it takes very few particles to fill up the same amount of space as it does for clay. Sand can often look like this. This is actually some masonry sand that I keep, there's a bag of it right behind me, and stuff like that. It dries out very quickly. The air runs through it. water runs through it. A lot of times this is a really coarse filter medium that you can filter out big chunks of things, like in a swimming pool. You can old filters often use sand that you would filter out big stuff. If you're going to filter out something fine, you need something where the space in between the particles is much, much smaller, and that's where you get clay. Now clay, because it packs so tight, it means that there's very, very little air in between the particles. It also means that water doesn't pass through this. As I said, I was moving a plant over the weekend, and on Sunday I dug a hole. It's up on a hill behind me here, and I dug a hole about this deep, not quite a foot deep, and it was filling with water. Why? Because the clay holds the moisture. And here's one of the reasons why. I have in my hand here a stack of washers, and these are just steel washers, finish washers. And one of the things about clay is that clays, once they get down to their tiny particle size, are often shaped like this, kind of like a plate. They may not be uniquely round, but they are kind of a plate. And the thing about plates is that they stack up on top of each other, and it's often very, very difficult to have any kind of space, air, or water can pass through in between. That means that this stuff can actually be used as a really fine filter, but it means you usually have to force the water through it if you're going to use it as a water filter. It also means that around here, the water that falls from the rain, by the time it sinks into the ground to recharge the groundwater, it takes a long, long time, as opposed to out on the coast where a lot of the layers are more sandy. So again, clay has these interesting plates that when you get in there. The other thing that clay does is, as the plates fit together, if there is water that's in there, this stuff tends to slide. It's called an elasticity. It can actually slide and move and make things. Now the clay around here in Randolph County, happens to be this lovely red clay or orange clay. And what gives it that orange color and what stains our clothing is the same thing as rust. It's iron oxide. It's mixed in with the plates of the silica, and it's actually in there, and that's what makes this stuff kind of red. It's one of the great things if you're making pottery, because this stuff, once you dig it out of the ground, you can get all of the small stones out of it and the impurities, clean it up, and you can make pottery. When you heat the pottery, firing is the process. You actually have to do it over a long period of time because there's so little airspace in here. Somehow you've got to be able to get all of that water out of there. So it can take quite a while to do that. So pottery is the earliest material that things like cooking vessels and bowls and things were made out of if you're a student of archaeology. That means, you know, human cultures and past things. I guess anthropology would be human cultures and things. But anyhow, so you have clay. Now, one of the problems is in the ground here in my yard. The clay itself holds water, which means it's muddy here a lot. I have constantly had to deal with the issues of mud sticking to the tread of my shoes. Sometimes I have one pair of boots that are almost smooth on the bottom, and when I get out here and work, the clay will actually stick to this smooth surface, and I'll get a big thick mat of it. I'll be walking along, and all of a sudden you realize, man, my feet are heavy. You look down, you got clay stuck to the bottom of your boot. That happens. The other thing that makes it kind of interesting is as over time and as people walk on it, the clay compacts and it gets really, really hard for water to get through that. So if you're a plant, you have to be able to tolerate life where you either get too much water or no water. And it's usually kind of a flip of the switch one way or the other. So if there's no other type of soil in there to give it texture, often we'll mix sand and clay together to give it some space so that the water can get down, so that air can get down to the organisms that are living in the soil and also to the root structure. But with clays, that often doesn't happen. So how has life continued on the planet for so long when you have so many places that are full of this clay? And there's an interesting process I'll show you right here. And this is what we refer to as frost heaving. When it gets really, really, really cold and the ground freezes, you'll hear us talk about a hard freeze. We had a couple of days back right before Christmas where we had some nights that were in the 20s and the top layer of ground froze. And so all of the water that was stuck inside the clay, in between the plates of the assorted clay, when the ground freezes, the water expands. And it's got to go somewhere. And so you'll get these interesting crystals that grow on the surface of the ground. They're being pushed up out of the soil as the ground freezes. If it had been cold for a couple of days like that and the wind was blowing, ultimately you would freeze dry the soil. But as the ice crystals push up, they make room inside the clay so that the grass, the clover, and the various things that grow in my yard are able to have some air that gets down into the roots. They're able to have a little bit of, they're small channels, like little honeycomb areas maybe, where the water can actually get down to the roots and those plants can get nourished. When the summer comes around, it rains and they pack down again. Winter, they spread out. So that's what a lot of this frost heaving is about. I was probably, I guess, in my 20s before I realized what this was. And I was out walking my dog years ago in my neighborhood. I used to live over in Chatham County, in northeast Chatham County, and was out walking, and I kept saying, look at those crystals, and they're pushing up from the clay. And that's what it looks like. This is the frost heaving that helps the soil get aerated. It gets more space. It allows water intrusion to get in there, and it helps the soil around here, the mineral dirt, to actually be suitable for a lot more different types of plants. That helps promote diversity. So the clay itself can do some interesting things that way. I'll try and find a picture or two of some other things that happen, but sometimes it means that the clay stays wet a long time, and wet soil sometimes, well, let's just say it's not quite as sturdy of a place for trees to grow. When the soil under the ground, the clay packs way down. Sometimes those trees have roots that grow out shallow on the surface and they don't go real deep into the ground. And that makes them susceptible to falling over when the wind blows. So that's one of those things that we find is pretty common right around here. So, talking dirt, talking dirty. Again, fine soil size, you have clays. The larger particles, you have sand. Clays, very tiny. Sand, somewhat larger. Clay particles, often shaped like a plate. Sand particles, not so much. So those are some of the real interesting things. Because we have this wonderful clay, we have a lot of pottery as an industry, as a cottage industry, and as a craft that's grown up here in this part of North Carolina. If you get on down towards Seagrove, it's very, very prevalent, and we find it all over the place. Good stuff, it can cause problems. Bad stuff, it can be beneficial. I know, that seems a little bit wacky, but that's the way it goes. The North Carolina Zoo. We're now past December, we're into January, and that being said, the zoo is still observing COVID protocols. That means that you will need to visit our website at www.nczoo.org. You'll need to buy your tickets in advance when you wish to come visit with us. You will also need to reserve an entry time. So those are some things that will happen along the way. Also, masks are now mandatory. You will need to have a face covering on at all times when you're in the park. Please help us help you to stay healthy and to stay safe. That's what we like. That's one of the things that I always talk about out here in the woods. When you're out in nature, you need to be safe. When you're even out in the zoo, we all need to be safe. So please help us observe that particular directive. For the North Carolina Zoo, I am Mr. Bob, your neighborhood naturalist. We'll be coming at you in a number of different forms through the spring, and we may be getting back up on Purgatory Mountain. I don't know if anybody got out to take their first day hike. It was a rainy mess around here, but still, I do know some folks that went. Hopefully you'll get an opportunity to come visit us before too much longer at the North Carolina Zoo. We look forward to your visit. So for the North Carolina Zoo, Mr. Bob, your neighborhood naturalist, I'm Bob Langston. Please get outside, enjoy nature, take care of yourselves, be safe, but please come and see us soon, all right? Thanks and have a great day. Bye now.